VK4GXC with another receiver review or receiver expose. What we have here is a Racal RA6217E, designed in the US Maryland Racal division in about the 1967s, I'd say, 66, 67. It was the first attempt at a fully transistorized solution, and it uses the Racal Wadley loop patent that they were using throughout the 50s and 60s, in that all the 1 megahertz selections were crystal locked, for want of a better word. It was basically a mix-up, mix-down solution with a mix-in of the RF VFO, which is actually at the back end tuning. It passes a plus or minus 650 kilohertz bandwidth signal fundamentally through the mixers, which are then mixed down at the end and tune across with the local VFO. Anyway, so it uses the Wadley loop. The configuration and frequency selection is very similar to the RA117, which was a later generation of the RA17. I kind of like this because it's a compact unit. It's in a 2U high chassis, and you've probably seen me do a couple of other receivers recently with the same sort of format, specifically the LTV receivers I did recently. And I have an idea I might sort of co-site this with an LTV, the VHF, and also got a UHF one on the bench at the moment. I'm going to go through and at some point bring it up to spec, and I have all three receivers in a single rack box. Anyway, that's the thought. Just above it is the wall sort of amp audio. One of the drawbacks of the Racal 6217 is there's no real audio amplifier in there. There's no speaker, there's no amplifier. There was an option to have a small amplifier fitted, but basically this is a sort of a line output level drive. So fundamentally, this is actually just giving us the audio amplifier output, and I'm just using a loop outside for some as the antenna at the moment. So I'll just quickly take you through it. As I say, it was a transistorized solution. It's a mixture of PNP germanium and NPN. Out of interest, this particular receiver was then sent to the UK in the late 60s, and it became the 1217 over there, and it had a number of obviously visual differences, although fundamentally it was the same core receiver. However, there are some shortcomings with the transistorized solution that was originally presented. Primarily it was to do with the AGC on this is not particularly good. I've had this on the bench on and off for over 3 months, and I've discovered five separate failings. Some have been the transformers have come loose. The glue has failed, and the transformers come loose off the board. There was a solder flash down on the 1 megahertz to 37.5 megahertz gen board, which reduced the injection. Although it was functioning, it was reduced by about 3 or 4 dB. There were a number of capacitor changes. Electrolytics have gone out, but fundamentally, most of them are the Sprague sealed tantalums, which are pretty good. So the two core design, because I kept thinking this has got to be better than what I'm hearing. There must be something not quite right. So I went through literally from the front end to the back end here, and it is now the most tuned and hyper-tuned receiver, I think, of its day, even by its release time. Having swept it with VNA and probed out a lot of the filters, it's now tuned spot on. Which has improved everything, but it's not particularly good at resolving SSB. The single sideband product detector is a little bit weak in this unit. I suspect the injection levels, it's just a low level product detector, and it doesn't do a very good job of it. Secondly, the AGC on this particular unit, even after all the fixes, is still a little bit light. It's cranked up to the max to try and capture the audio. Anyway, so those are the two issues, and both those issues were fixed up in the Racal 1217. I know, because I've got another one here. I know the story behind that too. So both the AGC and product were fixed up in the 1217. Anyway, I like the look of this radio. The reason I bought it, I really like the look of this. It's a very compact looking business UC type receiver. The intent was, it does not take much power. This is a fairly low, say it's all small signal, so it's a very low power unit. Was to just have this in the small rack near the desk and just have this on, over extended periods without any sort of worry about it going bad, to be honest, anything wearing out or getting hot. It'll just sit there and will go, and it does a very nice job of shortwave AM reception. Okay, quick go around the front panel. The main RF input can be set to wideband, or you can use a pre-selector unit. Now, in the wideband mode, everything's hitting this. It's basically just a dual stage, single-ended, low power RF front end. And it has a reasonably good noise figure. I should expect around about 3 or 4 dB, but the input intercept will be quite poor. Both stages are AGC controlled, and they do a reasonable job of that. But you really have to ride the attenuator to really get the best out of this. The dynamic range is not that hot. So the second thing is, when it's not in the wideband mode, you have this very, very fine tune, it's not quite the right word, very, very sensitive to tune pre-selector. Now, I went through this a couple of times. I was very fortunate, none of the cores were locked or anything. They all moved quite comfortably, so I realigned the whole front end, and that was one of the major aspects of this, to get that running well. And it does rely on you having a good 75 ohm feed, because if you try and use a long wire or something non-75 ohm, the coupling between the two, so it's basically inductively coupled, just does not behave the way you'd expect. It flattens out and you get two basic humps instead of a single critical coupling condition. To the right is the main service control. This allows you to actually power off the unit. There's a manual AGC, and then there's the short, medium, and long, and 2 cal positions. One for the calibration on the 100 kilohertz rolls, which I'll show you when I start operating it, and the other one is just to ensure that the BFO is centered in the passband. So there's a second VFO output here, which allowed you to inject an auxiliary VFO in to take over the tunable section of this receiver, and it allows I think at the time, a synthesizer solution, so you could have a secondary synthesizer above the unit and adjust it in. Now the 117 has that synthesizer. It's massive. It's like a 6U box. It's kind of quite interesting. Sort of here's my new watch, but here's the battery. Sort of look. It's a very small receiver, but with an enormous synthesized generated VFO. So I suspect it didn't find a lot of ground in the markets. Main meter here, it's a bit mean on the S points. It really does bottom out at the upper end here. It saturates out, and it's 2 positions, so you can measure the RF or the AF levels. Primarily to set up the 0 dBm output. And to the right here, we've got this small 10-turn pot here for calibrate fine. Look, the photos I've seen with this are mainly with another Raytheon, full turn adjustment here, which is this guy here as well. It'll do the same thing. This fine tune, it floats around. I don't quite understand it. It's run off a Zener diode line, so it shouldn't float around the way it does, but it doesn't seem to be very, very good. There's an adjustment. It sort of fluctuates, then settles. It's not really a particularly good fine tune. It's not as sharp as you might like it to be, or certainly as stable. Okay, so to the right of the calibrate tune button there is the detection mode. Now this particular unit has 5 filters: 0.2, 1, 3 kilohertz, 6 kilohertz, and then 13 kilohertz. The 13 kilohertz is always in line. So basically, what you just switch in and out the other 4. And for SSB, there's a single 3 kilohertz symmetrical filter around the IF, and you either mix it with a plus or minus 5 kilohertz offset to give you the 3 kilohertz bandwidth for SSB. That seems to work okay. It's fair. It's reasonably good. The 2 lower bandwidths, the 1 and the 0.2, are pretty good on AM. You swing it around to the the 0 BFO. You can do various offsets of the BFO for, I think, what was envisaged at the time of some data modes, but basically you set it to 0 and then you can off-tune the BFO here with as many kilohertz as you'd like. And there are some presets, as I said, it's +3, +6 to allow you to go up or down. I think this multi-carrier or single carrier but multi-sideband was certainly discussed at the time, and I think a lot of radio receivers had a go at this. Now, down here's the RF gain and the AF gain. This was majorly redone when it got to the UK. It's a dual gang pot with a 10K and a 500 ohm. This particular receiver, someone had blown so much deoxit in there, this is what I'm assuming, because it was actually damp and it was pretty grubby in there. The 500K was about a 2 or 3K, and the 10K is 32K. Now it's a dual gang pot made by CTS, and it's a nice design. It's one of their high grade pots, but there's nothing on the market to replace it. So I ended up buying a 500 ohm CTS single stage pot, and believe it or not, replacing the carbon track in this. You can drill them out and refit. It's very tricky, and you end up banging in 2 new rivets. Can be done. It was probably the most delicate thing I did on the receiver, but without that, at that low level, the agency is completely wrecked. They even have a select on test resistor across it, and I've put in the original value. I don't know how close it is. It might be why the agency is a little bit off, but I would have thought that they would have adjusted it until it just just had the right amount of gain to control it into the low level SSB product detector. Okay, so this is a trouble area. If you look at these, just double check and see where you are with these with this pot. If you might not be able to tell, but listen to the AGC, because it'll be shocking if it's bad. That's not the only problem though in the AGC loop. So to the left of that, we've got the main VFO unit here, which is very reminiscent of the R390s. It's the the Vida root sort of adjustment. So kilohertz on the right, and the interesting thing is it's counter to probably 9 out of 10 other receivers. It's a right hand sort of goes up in the frequency. Normally it's the other way. Normally it seems to be this way. Certainly it feels odd to me to use it, because I always end up tuning it the wrong way. And on the left is the megahertz control, which is basically a detented receiver situation. Now, one of the tells on a Racal system, if it's working, of this vintage, any Wadley loop, 17117, this guy, and any of the other ones, is that you, if you ever listen to, just put an AM, if you ever listen to these guys, you should be able to hear the mixer noise as you tune through them. Now, it isn't loud. I'll turn this right up, but you should hear as you go through it. So it's 9, 10. That's not antenna noise. This is actually mixer noise. If you can't hear this, then your 37.5 or your 40 meg filter's offline. So you should hear that. And this was not doing it when I got it, that's for sure. So you can hear all the way through. You're basically mixing in another 1 megahertz, another 1 megahertz, and vice versa. So I'll just bring that back again. Put the attenuator. And where were we? 88867. I had it tuned roughly to the local receiver, local aircraft channel here, and I'm not sure whether I've knocked anything else. Probably, well, that's okay. Oh, just go on. Yep. So as you can hear, the minute you get the antenna noise coming through, it's a lot significantly higher. But unless you can hear that that noise there, those steps. There's something someone showed me many years ago when I actually used to work at Racal. Anyway, so megahertz. The last thing I hadn't mentioned is might have a quick listen in a minute. The other thing I haven't mentioned is the attenuator, 10 dB steps, the attenuator. So here we are looking at the local. This is Brisbane, and you'll hear that the. In fact, I've turned this down a bit now. This is the RF gain. I tend to have to ride it a little bit, certainly at the bottom end here, else it'll just not. and I found just you've got to really rock it into the middle of this detent. You've got to go at the top here. I've just got my little loop antenna, which I haven't listened to, so yeah. Yeah, it's a bit quiet at the moment. Okay, so what I'll do is I'll quickly tune in the band, and I'll give you a bit of a talk through on the internals, and that should hopefully be it. But if anybody worth looking at buying one of these, look, I love the look of the receiver. It works really well for a 9068 HF receiver. It does have some shortcomings in SSB mode. The AM is fabulous. It's really very nice, and I can't. I can't push that enough. It is a very nice AM receiver, but for SSB, it did need a little bit more work, which was done in the UK, and the release is the 1217 there. So I don't think you'll hear much there. I might just quickly have a quick look at 20. It was pretty quiet. Let's go to 7. So you can hear the pre-selector is so sensitive that you just have to be a bit off tune, and you're literally just hearing the mixer noise again. You can hear it still in there. So we'll go to 7, we'll go to 40, and we'll just bring it down. One thing I like the look of the Raytheon nods here with the handle, but I find that I keep knocking it when I'm tuning, and going for the fine tune. Right, so we shan't be far off it, but we'll just bring it down to the next range. Okay, low sideband. Let's see if there's anybody on. That was there. Some interference always in this band where I live. Let's see if I'm a bit stronger. We're going to get lucky, aren't we? Let's go back. That's coming through okay. There's been an awful lot of people on tonight. I'll just also see if the New Zealand station's at 45. Yeah, there's there. So, just to give an idea of the AM. This is
tomorrow morning.
This is Radio New Zealand, which switches to 7:45 this time of the night. And I'll just get everything trimmed. You see how sharp that? It can be quite tricky to get it in. So this is 6 kilohertz, 13 kilohertz.
Violinist Jason Carter.
It's quite fair. It's good reproduction, to be honest. I quite like it. It's like the 1217. It always seemed to give a good account of a very nice quality AM output. Again, this is 2,500 miles away, so kilometers away. So it's coming in quite nicely. Can drive the turn it off, going down a little bit more, and you can get a little bit more linearity out of it. But then it's too much fluctuation. So that's the basic receiver. Just turn it down a little bit. Medium wave, DXing, forget it. It's just not capable down in that part of the band. You'd have to have significant external outboard selective pre-select filters. It just doesn't have the front end that's needed. Throughout the majority of the HF band, though, it's pretty good. I've had a lot of fun with tuning around. I've still a couple more things I'm planning to do to try and improve that SSB recovery, but it's a good receiver. Look, I wouldn't dissuade anyone from buying it. I really like it. I think it's a great looking receiver. Someone's fitted handles here with the rack mounts. These will come off when I put it in the rack, but for carrying it around, it's not too bad. I might even hang on to them for other radios. So I'll just lift off the gear here and I'll give you a bit of a talk around the insides there to make people aware of what is in there and some of the interesting characteristics. Okay, I'll talk through what we're seeing here. This is the top view. The whole receiver is in the main tray of the receiver chassis. There is an access panel on the bottom where they've got some reticulation of cabling, and the audio amplifiers in the base too. But fundamentally, 95% of the receiver is on the upper section, the upper platform, as it were. Over on the left-hand side is the RF in pre-selecting system. There's a number of filters towards the back here. You adjust them with a long tuning arrangement, a long trimmer arrangement from the back, and you go for basically a critical coupling on each band, and that is tuned by an input-output variable capacitor. Towards the back here is a two-stage amplifier and a low-pass 30 meg filter on the back. This is, again, to say, it's AGC controlled. From this part, it goes into the excuse me, the first mixer here, and the first mixer is then followed by the very, very often talked about 40 meg overcoupled filter here. This is basically a filter centered on 40 megahertz plus or minus 650 kilohertz, and that gives you your, and the reason it's slightly wider than 1 meg is there's a thermal consideration plus a little drift consideration of the VFO. But anyway, the mixer is basically a balanced mixer, high level injection, comes from the first VFO here, which is putting out 40 to 80 megahertz, that sort of range, and mixes the signal, incoming signal, up, or should I say, mixes with the incoming signal to provide the first IF or wide IF, whatever we call it. It's part of the Wadley loop system of 40 megahertz that comes through. Now, here, these two are cascaded. There's two units here, one above the other. It's quite nicely made. It can hinge, you can adjust them. I didn't quite work out what was going on here until a bit later, but this does hinge up, and you can get to the lower module. One is the 37.5 megahertz stepped, how can I describe this? Stepped output. So as you adjust the megahertz, it keeps mixing up that 1 megahertz, but although it comes through here at 1 megahertz higher, this is actually fixing a 37.5 meg mix signal, and that is selected by the 37.5 filter here. Now this is a traditional coupled, probably critically coupled, it's not overcoupled. You can potentially tune that with just signal generator, as long as you buffer it on the input and output, but you can tune that as a standard traditional filter. But this guy here really requires some form of swept analysis, so you know, your wobulator or your swept signal generator with a detecting system. I just basically use the VNA here to do this, and there's some probes. This is the second VFO, which is really the main tuning VFO. Nicely made, nicely geared, all backlashed. Tunes quite nice, has a reasonable light feel to it, quite nice. We ended with the second and third mixers at the back here, which fundamentally the second mixer brings it, the 37.5 with the 40 meg signals, down to a 2 to 3 megahertz output of band. That is also exported to the rear panel for a pan adapter. And here, the third mixer, that actually injects your VFO and mixes that to produce ultimately a 1.6 megahertz IF, which comes along this strip. These are all your IF filters. They're all crystal filters. As mentioned, the 13 megahertz filter is always in, and there's sorry, let's get rid of that. The 30 megahertz filter is always in, and you're switching in the other ones around it. This is actually, this NPC is not a filter, that's an amplifier, and I'm wondering if that was an afterthought. As I say, the gain is quite minimal on this. It's like there's not enough overall receiver gain to get the job done, and everything was pulled back, and then unfortunately it all compresses at a much lower level than normal. But that's hard to adjust. There was one trimmer on there, and you have to dismantle half the receiver just to be able to get into that and adjust that one inductor to ensure that it's at 1.6 megahertz. Now, the module here is the one which is the main a main focus, I would say, of most people's work and effort in getting it going. It's a sliding module. It can slide in from the back. You undo an RF connector and it plugs in through a cannon at the front here. And the cover then comes off. You can actually take the side cover off as well and slide it back in and do some minor adjustments when you're tuning it up. But there's the main IF amp, AGC amplifier, all your detectors. There is an FM board in this, by the way. I forgot to mention this FM demodulator in here. Not that I think many people would have used it. And then there's a converting system at the back, so that it could utilise some of the 455 or 100 kilohertz ancillary equipment. So if you have an RTTY demodulator with 455 input, you can fit the right crystal. There's some storage areas over here. You can see where the crystals used to be stowed. But generally it's not just a crystal swap, because the inductors and the filters in there, the hand wound filters, are pretty much specific to the crystal you're going to use. So I would imagine it would be a factory set. I'm still not quite sure why they had stowage for the crystals, but yeah, they are there. So that's where a lot of the effort will go. I would say probably about half my time was spent inside this box, aligning things and adjusting things and pulling out leaky low gain transistors and retrofitting them. Anyway, hopefully that's given a bit of an overview to it. And just one last thing, you'll probably see some resistors down there still tagged across. I'll tidy that later once they're fixed. But the pot, that was a problem, had to come over from down in there, and this is a welded up chassis. You literally have to take all the PCBs out and everything back to get the pot out and work on that. So there's the internal workings of the unit, and it's as I say, there's the megahertz adjust into the first VFO. When it's in zero, there's a couple of micro switches here, be aware of it. When it's in the zero position, it switches off all the certainly off all the AGC and I think the second VFO, so you can run a VLF adapter. And in fact, I think the VFO still is on, but certainly the IF is played around with. It inhibits the front section of the receiver and allows you to then inject your VLF in on the 2 to 3 meg signal in the back there, and you get the VLF bandwidth out of that. Anyway, hopefully that's enough of that, and I think it's probably a bit too long, this video, but just wanted to give people a bit of a look at what's been happening over the last few months here. Anyway, thank you for looking.